Part 284C3M1b7c8e13c9c6d3p34o. Line 22f1fa19c3m1b7c8e13c9c6d3p34o. Pulse wave velocity, Moens Korteweg 5G Wow Seti. There's the alien radio signal. And January 26, 2013, I was working on these keywords, and today's February 14th. So the keyword vet, Brunauer-Emmett-Teller, was Arrhenius law, and then line 22f1fa19c3m1b7c8e13c9c6d3p33 is Brunauer-Emmett-Teller Raney nickel metals 5G Wow Seti. February 3rd, we looked at the keywords Newton's law, classical wave, equations that led to our keyword wave velocity, to pulse wave velocity, to velocity of the forward traveling wave, and then we're adding Water Hammer and Moens Korteweg equation and pulse wave velocity. And that's from our previous video, line 22f1fa19c3m1b7c8e13c9c6d3p34n. Covariant closed string field theory 5G Wow Seti. Our keyword is pulse wave velocity, and we're going to look at that one first. Quotes from Wiki. Pulse wave velocity, PWV, is a measure of arterial stiffness. It is easy to measure invasively and non-invasively in humans, is highly reproducible, has a strong correlation between PWV and cardiovascular events and all-cause mortality. Relationship between arterial stiffness and pulse wave velocity. The study of the basic scientific principles of the velocity of the pulse wave through the arterial trees dates back to 1808 with the work of Thomas Young. The relationship between pulse wave velocity, PWV, and the arterial wall stiffness can be calculated from the first principles from Newton's second law of motion, F equals ma. Using some simplifying assumptions, the Moens Korteweg equation can be derived. An equation that directly relates PWV and arterial wall stiffness. So there's the equation there. The Moens Korteweg equation states that PWV is proportional to the square root of the incremental elastic modulus of the vessel wall given constant ratio of wall thickness, h to vessel radius r. Under the assumptions used to derive the equation, these assumptions being, oh, you know what? I didn't notice that r equals vessel radius. Now that could also go into a formula for our thing. Okay, under the assumptions used to derive the equation, the assumptions being there's no or insignificant change in vessel area, there's no or insignificant change in wall thickness, and that is small to the point of insignificance. The keyword measuring pulse wave velocity. Actually, I'm going to just add my thoughts here. R in line 17T2b, alien math equation, could mean R equals, what did I say? Oh, I wrote it down. About the radius. Vessel radius. Cross-reference at line 27. So that's just an easy way of doing it. Okay? So the keyword measuring pulse wave velocity, using the velocity of the forward traveling wave, PWV, by definition is the distance traveled. So there's the symbols, by the wave divided by the time. For the wave to travel, the distance of PWV equals wave divided by time, oh no, it's wave divided by time over wave divided by travel. This holds true for a system with zero wave reflections. The transmission of the arterial pressure pulse does not give the true PWV, as it is a sum of vectors of the incident and reflected waves. Therefore, appropriate pressure and flow measurements must be made to estimate the characteristic impedance and to calculate the incident or the reflected pressure wave at two separate locations, a known distance apart, although there might come conceptual problems with the term wave reflection in the arterial system. So the keyword Water Hammer and Moens Korteweg equation will be in our next video. So obviously this is going to have something to do with the long distance communication device because it's got your pressure, pulse, plus it's talking about waves and reflected waves. So I'm not sure where this is going. There's like several videos about string theories, and then there's like formulas from it afterwards. I tried not to do too many formulas this time because this is more like the learning part of it. Okay, so thanks for watching.